cleaning up bare pods. This is a new capability that we released in Kyverno 1.9, which gives Kyverno the ability to delete resources, clean them up based upon another Kyverno policy that you install. So Kyverno has long had the ability to validate, mutate, and even generate, as we saw in the first use case. But what we heard was there's still gaps that need to be addressed when it comes to a lot of these, especially platform and automation use cases that something like being able to remove resources would nicely complement. So we came up with this ability for it to remove resources based upon a new cluster cleanup policy or a cleanup policy. So here's the challenge in this use case that this solves. Very often when you're operating a cluster, we all run into problems during the course of operation. No matter how much you automate, no matter what you're doing in GitOps, there are always cases where a human needs to get involved and jump into a cluster and do some troubleshooting. Now, this could be doing things like ping check, name resolution, curling to another pod just to make sure that either the network is good or you have services that are up and running. But as commonly happens, we tend to forget about some of these things once the job is done. We put down our tools and we go home. So bare pods are oftentimes used for this type of break glass or troubleshooting scenario, and the word bare pod refers to a pod that's not owned by a higher level controller like a deployment. A bare pod is oftentimes created imperatively using something like a kube control create or kube control run command. And once those pods have done their job and users and operators have execed into them or done whatever they need to do, they might still be running out there. And in cases where you might be running Kubernetes in a public cloud environment, this can incur additional costs because you multiply this by multiple teams and multiple namespaces. It's not uncommon to see maybe many of these pods that are running out there, and that could become fairly cumbersome and introduce a lot of clutter. So what we could do is use Kyverno to help us solve this by scouring the cluster and finding these bare pods, and if they exist, deleting them. And it can do this on a scheduled basis rather than just running an imperative command one time. So that's what we'll show here. We've got a bunch of different namespaces with these bare pods, and we're going to create a new cluster cleanup policy, which will look across the cluster and find all of these bare pods across these namespaces, and it will remove these for us. So let's flip over and show this. So similar to what I talked about in the second demo, we need to grant Kyverno a little bit more privileges here. Specifically, we need the ability for it to remove pods. And it's necessary for us to list and delete these. And you'll notice again here, we're not having to modify one of the main or the main cluster role. We have role aggregation that's enabled. You can create a simple cluster role like this, and as long as the labels are installed, it will get aggregated to the base cluster role, and Kyverno will be able to do its job. So let's first give Kyverno these privileges. We've done that. And now let's create some bare pods. So you've noticed here, I like to use BusyBox as a very simple container to illustrate a number of things. And we've got a number of BusyBox pods that are just going to go into another sleep state across a bunch of different namespaces. So our ing namespace, our platform namespace, and our existing namespace. We're just going to simulate some bare pods. Now, you've noticed here, these are just your standard bare pods. They're not owned by a deployment. And so let's go ahead and create these. And we have some bare pods that are now out there running. Now let's take a look at the new cluster cleanup policy that comes with Kyverno 1.9. So in this cluster cleanup policy, this is a new custom resource. You notice the previous ones were cluster policies. Well, we've introduced a cluster cleanup policy, which is similar to other Kyverno policies, except it is only specific to the cleanup ability. And what we're doing here is matching on all pods, and you can, if you're not familiar with Kyverno, you can see kind of a common theme here that the way that we declare policy is all standard YAML using constructs and patterns with which you're likely already very familiar on account of having to do these probably on a daily basis for more than just policy, for things like pods, certificates, even ordering whole clusters you can do with simple paradigms like this. So we want to be able to use those same constructs in policy. And so we're just matching on pods. And also, we're going to look into those pods. And now, what we're doing here is we're looking at the owner references key. And the owner references object that's in a pod is where a pod would declare another ownership. So, for example, if you had a deployment that was spawning pods, those pods would have an owner reference back to a replica set, for example. And these could be owned by something else or even multiple potentially. But we're specifically looking for pods, and target refers to all of the existing pods that are found out there, not new pods that are coming in. It's only looking at the existing ones. It's returning all the ones that have empty owner references, because those are the only ones that we're interested in. And then our schedule here, which is a common cron format, we're going to run this every minute. Now, I'm only doing this for the purposes of this demo. This is probably not something that you want to do in a live environment, but in the interest of time, I will go ahead and create this. And what we expect to have happen is from the moment that I create this, it'll start its countdown. When the schedule elapses, Kyverno is going to kick in. It's going to look across the entire cluster for pods. It's going to crack each one open and evaluate this, and it's going to make sure that it does not have an owner reference. If it does not have an owner reference, it's going to gather them all together and then immediately delete them. So let's create this and see if it actually does that. So I have created our clean naked pods cluster cleanup policy. And so let's go and look at these bare pods, and I've assigned a label to them for easier tracking. So let's get pods across all namespaces that have run BusyBox associated with them, and we will watch them. And since these are all in a running state, these have done their job admirably. They're no longer needed, yet they're still sitting out there and running. So once the schedule has elapsed, Kyverno should be able to find just these pods, but not any other pods, because these are the only ones that are bare, and it should call out to the cleanup controller and have it remove them. So what we expect to see, as which is what we're just now seeing, is these pods go into terminating state because Kyverno has ordered their deletion. And once this termination state finishes, these pods will be removed from the cluster. And if we check again, they're still in terminating state, but in just a moment here, once those processes exit, these pods should be removed from the cluster. And so we'll trust that that'll happen here. And there you go. So pods, our bare pods were just removed, but the rest of the pods that are owned by controllers, they are still present. So let's clean up here. And let's flip back over for the last use case. So anyway, as you can see with this use case, this can be super useful for cluster admins and platform teams because it can remove a lot of cruft from your cluster that you may not be interested in. And operators and financial teams typically like this because this oftentimes has a real cost savings that's associated with it. Now, I'm only doing I only showed a very simplistic use case here with cleaning up pods, but you can imagine this could be any resource and even multiple resources across your cluster with some very complex conditions that you use in order to reduce the number of matches down to only the ones that you care about. So hopefully this was an enlightening use case on how you can maybe operationalize these types of cleanup policies.